Assalamualaikum and good day everyone. So we will continue with our week 8 lecture, which is going to cover whatever after multiplexer. Okay. In the previous lecture, we have learned about multiplexers. Okay, you can refer to your previous lecture and also module. And please do make effort to make exercise. Okay, or from the module, from the test. Okay, and if you have any problem, feel free to approach me and we will discuss the answer or questions via uh, forum platform or also in WhatsApp. But it's preferable in forum so that we will have centralized content, okay, for whatever issues that you guys may encounter. Okay, so you can always refer back instantly, okay, rather than putting at WhatsApp and we need to browse each and every text, so it will be complicated that way. So week 8 we will cover in the second lecture is the about the demultiplexer. Okay, if you guys can see, okay, this is what have been given from your course informations. Okay, week 8. So this is the second part of the lecture that we'll cover today. It's about demultiplexers, concept, device, code converters, expansion, implementation of Boolean function using multiplexer and decoders. Okay, and please do not heavily rely on the slides. Please make effort to read modules and any information that you think is relevant. Okay, you are a university student and you are expected to do more independent study and not I'm doing spoon feed. Okay, uh, we are not in the era of secondary school, primary school where you guys are fit with things. Okay, so please do more independent study, and of course I'm here if you need me. Okay, demultiplexer demarks. Okay, as I did some briefing, a brief lecture about demarks, it perform actually the inverse function of the multiplexing. Okay, the demultiplexer has one input and selector inputs and selector input and two n outputs. Okay, so demultiplexer usually written as one xy or one y, where y is the number of the output data lines. Okay, example, if you have a 4 output data line demultiplexer, then it will written as 1 to 4. Okay, means this is 1 to 4 means you have one input and you have 4 outputs. Okay, and dmux. Okay, dmux is the short form of the name. So when you are ever mentioned as demultiplexer or dmux, you should know. But this one is quite easy and it's easy to guess. Unlike wedge diagram, is also okay. When I asked in the previous class, what in the quiz one, what using the word wedge diagram, everyone didn't know about it. Okay, so but it's actually KMAP. Okay, so please do more reading and so that you will know more better and do more exercise so that you can take the question properly and at best to solve them. Okay, so this is the 1-2D marks is one input and two output, consists of one input, one selector and two outputs. Okay, so it have one input and n selector input, okay, and two n outputs. Okay, so this is symbol for 1-2D marks. Okay, function when you have d0, when s is set as 0, your selector, then you will have d0 equals to d and d1 equals to 0. And when with this we means that d0 is actually your d dot your s bar. Okay, s bar here is actually here because it is 0. And when s selector is set to 1, then you will have d0 as 0 and d1 as d. Means that your d1 will be d dot s, okay, multiplied by s n, okay, n function. So whatever d value that you have, it will be translated here. Let's say if your d0, let's say if your s0, okay, let's say if your s0 and your d currently is 0, okay, so 0 times 0, you will have d0 s0, okay, and d1 d dot s, you will have this. If 0, then you have another 0, then you have what? Okay, so you see, when s is equals to 0, your d0 will be your d. Okay, we follow like 0, for example, just now I say is 0, okay, and your d1 will be 0, okay. And let's say if your s is 1, if your s is 1 and your d at that time is 0, okay, that time is 0, so your d0 will be 0 and your d1 will be d, means it will be 0, okay. So you see, the function table is actually the compact form, okay. You can say it's a compact form of KMF, but because a compact form of truth table, sorry, because it shows the function, okay, the function rather than showing all the possible combinations, okay. So you have S. If you have S selector of possible possible input of 0 to 1 or 1, okay, here, then your D1 or D0 of your output will have 0, D, or if you have 1, it will be D and 0, okay. Sorry for a bit confusing parts of the first explanation just now, okay. Because I'm recording, it's quite late now, it's around 2:30 a.m. okay, so it's easily to be a bit uh, mistakenly explained, okay. I'm sorry for that, okay. So here is the logic circuits, okay, for 1 to 2 demarks, you can see, right? So S, you can have either 0 or 1, so this one logically will be, let's say this one will be your 1, this one will be your 0, and then your D as the inputs, okay. Then you have output which is 2, okay. So here you can have 0 or 1, then you will have results, okay, means you have to output. So you can try, okay, test yourself, okay, don't just see my slide and as if you like watching movie with popcorn and without doing anything. You try this concept yourself, okay, you put the numbers and you see what is the results, okay. You test with 0 1 here or 0 1 here and see what you have, okay. Please do more exercise, okay. Next is 1 to 4 demarks, okay, which is consists of one input, okay, the same one input, and selector input, which is 2, and 2 to the power of 2, 4 outputs, okay. So similarly, as in the demark 1 to 2 demarks, so but we expand them, okay. Now we have S1 and S0, means we have 2, and we have 2 to the power of 2 combinations, okay. That's why we have 4 combinations, okay. So if we have 0 0 0, all the beginnings, okay, the most significant bit, you can say most significant bit, that M is 1, 3 most significant bits is 0, while D0 will collect the value from the input D. If you select this combination of selector inputs combination, then you will have 2 most significant bit as set as 0 and the last significant to be set as 0, and you see D will follow the value of the input. So if you see, just similarly like 1 to 2 demarks, okay, the value change, okay, the output value change accordingly with D input following the selector combination inputs, okay. So you can see, right? So it's very direct. This one similarly with the 1 to 2 demarks, okay. And like I said, please try to test the concept, okay. Don't just watch this and expect that you understand. It will not work that way, okay. Why? You will know that it will not that way when you feel it's a bit complicated. You cannot answer the test question effectively, or maybe you lost. Okay, lost means that you don't understand at all. Okay, so please do exercise. Don't just see this lecture and you assume it's adequate. No, it's not going to work that way. Okay, so like this, if you see, This is the logic circuit for 1 to 2 demarks. Okay. So now try to guess what is the logic circuit. Okay, you may try yourself. What is the logic circuit for 1 to 4 demarks? Okay, try yourself. Okay, and you can always test the results. Is your logic circuit is correct or not based on this truth table. Okay, please make effort. Okay. So the next is decoders. Okay, the decoder. What is decoder? Okay, decoder used to detect the presence of specified combination of bits. Okay, to detect presence of specified combination of bits. Okay, on each input and indicate the presence of that code by specified output level. Okay, it has n inputs, 2n outputs. So the way we're describing them is n to 2n. Okay, decoder. So decoder can be designed as 1 to 2, okay, 1 to 2, 2 to 4, 3 to 8, 4 to 6, etc. They say if you have 5, it's 5 to what? To 2 to the power of 5, which is, if I'm not mistaken, 32. Okay. So if enable input is present, it must be asserted to enable decoder function. What does it mean by this? Similarly, when we have in multiplexer circuit, we may have enable, right? So if enable is active that time, then the decoder function is enable. However, you guys need to able to differentiate if your enable is active low or active high. What does it mean by active low? I have explained in the last class of multiplexer, but I explain again so that you guys may need some refresh. Active low is that if we put 0 to the enable, it will be active. Active high is that if we input 1, logic high 1, then it will be active. So active in the sense that it will active the decoder function of that chip or multiplexer of that chip. Okay, depends on what chip, the chip of interest. Okay. So 2 to 4 decoders consist of 2 inputs and 4 outputs. Okay, here is your inputs and this is your outputs combinations. Okay, so because we have 2 inputs, so we have 4 combinations. Okay, 4 possible combinations, and we're going to choose. Okay, we're going to choose the specified output. Okay, when we already select certain inputs. Okay, for example, if you select A1 and A0 equals to 0, 0, okay, what will be your output? Okay, what will be your output? So you can see here, the O3, O2, O1, and O0 is your possible, if your combination of outputs. So you have, if A1 is 0, then your output will be 0, 0, 0, 1. Similarly, if you said A1 is 0 is 0, 1, then your O3, O2, O1 output, okay, you will have your 1 here. Okay. So here, by concept, you can see that your OO, okay, output of 0, 1, first output, which is output 0. Okay, you guys need to understand, okay, and not to mix up. Let's say if I mention first output doesn't mean O1. Okay, it means actually first output is O0, second output is O1. Okay, so it's understand, right? Because it's not in the real world where we actually 1 is actually referred to, first it actually refers to 1, but in digital, no, the first is actually 0, right? So this is your first output, will be based on A1 and A0. Okay, and output 1 will be based on this combination of 0, 1, and so on. So this is your function table. Okay, and you can see that the output of 1 is changes with respect to the variation of input combinations. Okay, so this one is I think is pretty straightforward. Okay, of course you guys need to do more exercise in order for you to be able to to solve problem regarding decoders in exam effectively. Okay, So typically decoders, okay, typically, but doesn't mean that it's a must. Okay, design as active flow, just like what I told you. When it is active flow, then the decoder function is active. But if it is high, if you input high to the enabler, then your decoder function is not activated. Means the chip will not perform decoder function. Okay, so symbol for active low 2 to 4 decoders. Okay. Sorry, this one means the output. Means the output is active low. Okay, not enabler. Enabler it will mention in some way, and it should be you should have enable here. I'm sorry for that. Okay, for the explanation just now. So active low is the output. Okay. So what is active low? Simply means that you have bubbles. Okay? Bubbles here is to invert your outputs. Okay. So instead of having 1, you will be having variation of 0 at the output. Okay. So similarly, this one is just similarly with the previous active high 2 to 4 decoder here. Okay, but you just have additional inverted bars here. Okay. So when A1 A0 for equals to 0 0, then for output you will have you have 0 at your least significant output bits. Okay, here. And when your A1 A0 is 0 1, your 0 will be at your second least significant bit here. Okay, so similarly, okay, with the 2 to 4 active high decoders, you will have variation of 0, okay, versus 1 as in the active high decoders. So you see there is 4 possible combination of inputs. One, then you will see that there is a variation of changes in your position of 0. Other than that, all of them is 1. Okay, so please you may try to do the logic circuits. Okay, try to draw the logic circuit and to see what you able to get, and make sure your logic circuits can perform this function. Okay, so logic circuit, as you may see, you can see okay, you may see from the module. Okay, the decoders is actually chapter 9. Okay, chapter 9. The 9 of the module. Okay, so the module should explain more and extensively about the decoders. Okay, about the decoder. It is from page 105 to 118. Okay, to test your understanding, you may do exercise. Okay, module exercise 9.1 to 9.8 at page 118. Okay, so please make effort. Okay, don't just simply that you score A without doing any exercise. That is impossible. And for those that not having the module, I have been repeatedly and share with you guys since the beginning of the class. This is the module. Okay, so if you know yourself that you didn't have the module, you should have double or triple effort compared to your friend. Okay, because module have shown what the syllabus that what you should learn, but how you going to study without having module? Okay, I'm not sure. Okay, it depends on you guys. Okay, you may ask your friend maybe to snapshot each page for you. Okay, that's why you have your friends. So please, okay, make effort. Don't just sit there and because it's a bit difficult, I believe, not having the books. Okay. So 2 to 4 active low. Now we see with active low enable. So your enable is active low. What is the active low here? is because you have bubbles. Okay, so if E equals to 1, okay, which is the when this is happen, the chip will not perform decoder function. So at this stage, it doesn't care what is the input combination. So it doesn't care. So your input will be X and X. A1 will be X and A0 will be X. Because at this stage, it doesn't care about the inputs, because at this stage, when the enable is 1, the chip didn't perform decoder function. Okay, you can see here, okay, if you have U1, and it will not consider any variations of inputs, because it will provide all 1 for the output. Why is 1? Because this is active low output. Okay, however, when we start to put zeros, okay, at this enable, then the chip will perform decoder function. Okay, so this just extension from the previous page slide, okay, with the enable function here. Okay, so you have zeros here, change with respect to the A1 and A0. Okay, um, okay, just maybe to make your life easier, even though I asked you guys to make effort to make a logic circuits, okay, you may refer to page 106, okay, page 106 of the module. You can easily see the logic circuits of the decoders, okay. So I'm not sure if you guys okay, I don't know how to actually show this to you guys, because I have opened a module, but okay, I try to draw if it's possible. Okay, so if you have 4 outputs, so you will have 4 outputs and get, okay, and this is not related, okay, it may relate or may not related from this truth table, okay, because I directly take from page 106, okay, just to make your life easier. What is the logic circuit for the decoders, okay. So we have not get here, and you have your A, and you have your B, oh sorry, A1 and A0, okay. Okay, so this is the arrangement, okay. I draw it very fast, okay. Okay, sorry for the bad drawing. And then from here, okay, okay, then this one, okay, so A1, okay, here, okay, you guys can draw it better later on, okay. So just to show I'm just showing this for the benefit of those who doesn't have module. But the one that doesn't have module, don't expect me to provide everything as what module shows, okay, because that's why you should have the book, okay. And A here, okay, here, here, I guess. Okay, so now I want to check if we actually have that. Okay, this one is incomplete, so this one is from here. Okay, so I think now it's complete. Let me check. Okay, so this is it. Okay, so this one is for is not directly relate with this diagram. Okay, with this, because this one is an active low enable. Okay, what I'm drawing now is active low, active high. Okay, with active high output, active high output. Okay, here is active high output. This logic circuits. This one is for active high output. Okay, so you see now, for this kind of logic circuits, okay, you see you have y0, okay, y0, a1, a0 here, okay, and how about y1? Okay, it's not directly related to this diagram. Okay, I just make a repetition again because I'm considering you guys those who doesn't have the module. Okay, so a1, b, a naught, okay, and then you have y2, okay, y2, a1, and a naught inverted, and y3 we have a1 and a0. Okay, so this is the example of the logic circuit for 2 to 4 decoders of active high output. Okay, so it's not uh, directly uh, similar with this, because this one is active low output, this one is active high output, this one is active low input, so it's not the same. Don't confuse yourself. Okay, so of course when you want to produce active low output, you just simply put in bubble here. Okay, bubble at the end of this. Okay, then you have your active low output. It's quite easy actually. Now we go to the decoders IC. Okay, we have 74 times 139, 2 to 4 decoders. Okay, 74 times 139 contain 2 to 4 decoders. Okay, to use either decoders, it must be enabled by inputting low signal at the enable input. What does it mean by this? This is what I explained just now, is an enable active low. Okay, where you can see that actually here. Okay, active low. Okay, the bubble, right? So when enable high, all output high. Okay, when your enable have logic 1, because it is active low, right? So your whole output will be 1, because if you can see, you should be expecting um, active low output. Okay, because this is inverter. Okay, so if it's enable high, okay, if it's enable high here, if it's enable high, means the chip doesn't perform decoder function, that's why you have all 1. Okay, but if it's enabled low, okay, then your chip will begin to perform decoder function, then your output combination will not all be 1. Okay, it will have zeros at some of these combinations. Okay, so you can see, okay, this is the marking. Actually, this one to help you to know where is the chip starting from. Okay, then you have 1, 2, 3 is the pin number, okay, of the chip configuration, and this VCC is the supply voltage. Okay, and this one is ground. You guys know, right? Everything in circuits we have to have supply voltage, and of course we need to ground them. Okay, so this is the variations of the outputs. Okay, to A. Okay, this one is the input. Sorry, this one is the inputs. Okay, to A0 to A1. Okay, and you have one A0, one A1. Okay, two, and then you have two Y0, two Y1, two Y2, two Y3, one Y0, one Y2, Y1, Y2, Y3. Okay, so this is the pin configurations. Okay, and this is the logic symbol. I think this one is more understandable. Okay, I think you guys might confuse with this, but this is to show you guys what is the pin configuration. But in the exam, I hope you guys able to understand, able to convey them properly. Okay, both of these, even though is it in configuration or in logic symbol. You can see right here, you have you have four combinations, input combination. Okay, you have this. Then that's why you have this one Y1 with, and then you have two Y combinations. Okay, so function table for this for the chip just now. Okay, n number of enabler. Okay, you might have more than one enable. Okay, please remember this. And when if it's high, so it will not consider the input combinations. Okay, whether it's 1 or 0. That's why we have don't care here. And remember, when we mention n here, means that it can be many. Okay, it can be many. So please understand the symbols. Okay, so if it start to have low, means this chip will perform decoder function, and it will start to consider the input combination, so that we will provide the specified combination of outputs, right? So when it is high, the chip didn't produce this decoder function. That's why all of this will be high. High because we have active low output. Okay, and when we have low at enable, so the chip is enabled for it to perform uh, to perform decoder function. So we will start having low output at the active low. Okay, with respect to the combination of the inputs. Okay, so here you see this is the least one, Y0, Y1 and Y2. Okay. Don't let this fool you. Okay, sometimes you can have 3 to 1 0 combination like this, so please read properly. Okay, so you will have output combination of low at these orders with respect to the combination of the inputs. So output depends on input A with enable equals to 0. Enable 0 because this is active low enable. Now, similarly, okay, with 3 to 8 decoders consists of 3 inputs, okay, and 8 possible outputs. Okay, so these are active low decoders because we have active low outputs. Okay, all of them having bubble. Okay, similarly concept. Okay, the concept is similar. Okay? The concept is similar. It's, you just extend it. You have now you have two. You have 8 possible combination of outputs inputs. Okay, and that's why you have corresponding 8 possible combination of outputs. Okay, with of course 0 is at changing at the changing bits. Okay, now 3 to 8 decoder consists 3 inputs and outputs. Okay, this is the function table just now. Okay, so you will see that your position of 0 for the active low output is changes. Okay, so it's easy. The others are 1. Okay? So please don't assume this case to be always very valid. Let's say you are given the 3 to 8 decoder with active high enable, means it will be inverse. Instead of you having changes of 0 at your output, you will have changes of 1. Okay, so please try to understand, and to make sure that you understand actually right, when whatever question given to you, you can answer because you have that fundamental of understanding. However, if you think that you understand, but if you think you understand but you're unable to get the question properly, then your understanding maybe still have some lacking. Okay, so how to help you with the understanding is for you to do exercise, to do a lot of exercise, okay, and to read, okay, independent study. Okay, now 7 to 8 times 74 times 138 contains 1328 decoders. Okay, this is a popular device. So if it's popular device, maybe a popular question to be asked. I don't know. Depends. So it has 3 inputs, 3 enables, and 8 outputs. Okay. So this one is we know. Okay, and input is why we have output of 8. Okay. So we have enable. We have 3 enable functioning. Okay. And this is our select input. Okay, our input, and this is our output. Okay, we have a lot of output, right, from y0 until y7, and this is your supply voltage, and this is your ground. Okay, and you see it is an active low output because you have bubbles at your output. And we also know that you see the enable, don't assume, you see the enable for G1 it is active high, and for the G2B and G2A it is active what? Active low. Okay, so this is the truth table, okay, of the 74 times 138 328 decoders. Okay, so you may see this truth table, okay, and try to understand them. Actually it's just similar, it's just that we have more enable now. Okay, we have more enable now instead of only one just now, right? Okay, and then so please see note 1, G2 is equals to G2A plus G2B, and this is, when you read, don't just read halfway, okay, you need to read all in order to grab the full information. Okay, and then it mentioned here is output is enabled only when G1 is 1, G2A is 0, and G2B is equals to 0. Okay, so you are given this, so you may test yourself, you may test and try yourself. Okay, and you may understand it that way by doing more exercise to try to see the what is actually happening. Okay, with this 74 times 328 decoders. Okay, so now we go to the next one is the Boolean function using multiplexer and decoders. What is the Boolean function that we can try? We may get when we deal with multiplexers and decoders. Okay, so for example, given f ABC, what is ABC mean? You have input of ABC, then you will have, this is what, this is min term, shorthand min term. So you have min term at 1, 2, 4, 5. What does it mean min term? This means your function of 1, output 1 will be at the first, your output of 1 will be at this 1, 2, 4 and 5. Okay, outputs. Okay, so implement using 8 to 1 marks, 4 to 1 marks, 8 to 1 marks, 3 to 8 active low decoders. Okay, so we try to see if the solution is using 8 to 1 marks. Okay, multiplexer now. Multiplexer is what? Multiplexer is what is okay. Let me provide some definition first in case you guys lost. Okay, because this is from previous chapter. Multiplexer means many into one. Okay, so many into one. Instead of, unlike the decoders, okay, decoders is inverse. Sorry, the multiplexer is inverse with demarks. Okay.
Sorry, I can't do.
Okay, now you have now because it 3 inputs, so you have 8 possible combination of input because 2 to the power of 3. Okay, then what happened to your function output? Okay, you have 1, 2, 4 and 5. Okay, as your shorthand min term. So what is that? You will have 1, at each of this combination of inputs. Okay, this is your 1, this is your 2, this is your 4, this is your 5. Okay, So following that, we will have function of 1. Why is 1? Because we are using shorthand minterm. So this is your marks add to 1. Okay, add to 1 inputs and add inputs to 1 outputs. So you have this VCC as supply voltage. This one is your ground. So you guys will get group assignment. Okay, group assignments using, I'm not sure, I will decide, or maybe later on, is using quarters 2 or multi-sim. Okay, so you guys will do, I think, to do some circuit. Okay, so you have D0 until D7 as your combinations of what? Combination of combination of, this is the pins. Okay, the pins, and this is your ABC, is your input. Okay, and this one is your output. Okay, because it's F function. Okay, so this is the active, this one is inverse of this perhaps. Okay, so okay, so just okay, and this is your ground pins. Okay, so I think you guys can see, right? If this is ground 0, means you will have 0 here. What else? You have 0 here, you have 0 here, and you have 0 here. Okay, and what is VCC? Means you have your 1 here, your 1 here, your 1 here, and your 1 also here. Okay, so now you understand. I hope you guys understand, right? Why we have VCC at this inputs and why we have ground. So it's actually translated to 0, logic 0, and logic 1. Okay. Now similarly with solution using 4 to 1 marks. Okay, 4 to 1 marks. So you see 1, 2, 4, 5. Okay, so you have this one again shorthand mean terms. So you have 1 here, 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 and here, which is actually the first, the second, the fourth, and the fifth. Okay, inputs. Okay, input combination. I mean, this one is zeros. Okay, zeros where you have actually 0 value. This one is you have value of 1. This one you have value 2, 4, and 5. I think you guys understand what is this, right? This one. The weightage. Okay. Now, so when we try, okay, now we have, just now when we have to, this one is using 4 to 1 marks. Okay, 4 to 1 marks. Sorry, this one is, so the previous is using 8 to 1 marks. So it's nice that you already have 8 possible inputs to be input combination to be considered. But how if you suddenly you need to do some maybe cost saving? For example, you need to have some cost saving. You still have 3 combination of inputs, but you now limited to 4 to 1 multiplexer. Means you need to use smaller, and you need to use chip with smaller input combinations. Okay, so for this, like this, it's 4 to 1 marks. Okay, so what you guys can do is actually, you of course the first thing is you divide this, because you have 8, right? You can just simply add this with like this. Okay, divide by 4, because now, because you only have 4 possible combination, okay, of inputs. So what happens is F, here you can see F following the C. Okay, here F is equals to C bar, here F is equals to 1, and here F is equals to 0. So what does it mean by this? Okay, this C is actually introduced, okay, because we try to simplify. We try to simplify, or we try to make compact the combination inputs from 8 to 4. Okay, this is the C, so it is being introduced here. Okay, so let's say we assign C to be 0, 1, 0, 1, 0, 1, 0, 1. Why is it? Because C is only one bit, so it can have either 0 or 1. Okay, so simple is that you now provide, okay, you now see that F here will be following C, okay, for these first combinations. Okay, you see F and C, they are the same, 0, 0, 1, 1. How about this stage? This second possible combination is F is actually inversion of C. Here, at the third combination, is that the F will always be 1, okay, regardless of your value of C that you have, okay. And the fourth one, your F is always 0 regardless of what C you have, okay. So you still have zeros. So you can make them into you now can transfer them to your circuits, okay, to your circuit and your chip, okay, marks this 4 to 1. So now we have A to B only, okay, instead of having C as the third combination, because you don't have that luxury to have 8 to 1 marks, okay. So this C is how you implement your C, okay, at your D0 and D1s. So you may have C either to have 1 or 0 value, okay, for example, okay. So this is your function, okay. Y and W is the inverse of this, okay. And of course it's ground, okay, ground. So for example, you see the location of your VCC. Here is 1, and here is 0, okay. So remember, this chip is multiplexer. So what should you have in multiplexer? Multiplexer have output, have selector input, and data input. So A and B is what? AB can be what? Please, you guys can try to answer my question, okay, for your understanding. So based on this chip, okay, you can see this is 4 to 1 marks, right? So where is actually, which pins is actually your data selector input, which one is your data input, and which one is your data output, okay? So clearly that you have AB here. Okay, what is the AB here? Because AB is the one that changes, and when AB changes, it will decide which of these D0, D1, D2, and D3 to be considered, okay, for your Y, for your output Y, okay. So I give them in words already, so try to understand and try to maybe to make a logic try to make the schematic diagram out consists of the logic gates, okay. So similarly, okay, now if we try to solve using 2 to 1 marks now, so it is much more compact, okay. So similarly process is observed. So now you divide the whole things with the equal two portions, okay, because you're going to have only two possible value of inputs, okay. Inputs here doesn't mean the inputs, I mean it can be selected inputs, okay. You need to know, doesn't mean that input is totally the input, okay, because multiplexer we have data selected input and we also have data input. When I refer to input, it can be data selected input or it can be inputs, okay. So similarly with this, okay, you have this. So you see, when now we try to use, instead of just now we use C, now we use A. So A, you have two possible combination of A here, right, which is 0 or 1, okay. And you have this is the corresponding outputs, okay, following the shorthand method here, okay. So you can see the F is equal to B bar plus B bar C. This one is actually what? This one is actually B XO C, okay? And this one, F in comparison, okay, your F now is you try to see this what things that can be consistent, okay? Then you make a equation like this. F is when you see this one is always inverse with this one, okay? This one always inverse with this one, okay? So that's why you can relate F is, it will be following your inverse of B, okay? You cannot use C here because C they have different combination that is not that you cannot make it consistent to obtain an equation, okay? So you see it is XOR and also the NOT, okay? And you see A here, okay? A is your data selected input now, okay? Data selected input. So your A can be 0 or 1, okay? And of course, this is your output and this is the inversion of your output, another output, okay? So this yes, using the softwares, okay, I am expecting you guys maybe to do, maybe, okay, I'm not sure yet, to do some group assignment, okay, using this kind of things, okay, where you need to simulate and see the chip and the things you try yourself, okay, with the with the chip from the library, okay, from the software. Okay, now exercise given Boolean expression AC, A bar C, A B C, and this one implement using now. You try to implement using this then. It is exercise, okay? It is exercise. So you try it yourself, and if you have problem, you can approach me. And of course, don't come with me with blank paper and expecting me to fit you with answer. It's not going to work that way, and it will not help your understanding actually. You need to try first, and when you have problem, you ask me, and we will maybe discuss in forum so that everyone will have the will have that information of what you have been trying to solve, but you cannot do it. Okay. But at least you must, before come to me, you must try. Okay, when you try, is you can see your effort there, and then when you try, you know what you didn't know. If you didn't try and expecting me to give you answer, you didn't know what you didn't know. That is the most terrible situation for a student, because if you're given a question regarding these things that you didn't know, that what you didn't know, I'm pretty sure you maybe cannot able to answer that question properly. Okay, and worse, maybe you get it wrong. Okay, so decoders will be covered, okay, in the later weeks. Okay, so we will skip this part for now, and assalamualaikum and goodbye. See you again in the next lecture. Okay, thank you very much.